Now on to part 2 of module 0. In part 2, we are going to try to find the density of 3 different unknown liquids. We have some unknown liquids in these containers here. We also have a number of unknown metals. These metal cylinders here. We're going to pick a couple of these and try to find the density of these as well. Since density is an intrinsic property, meaning it's a property that does not change no matter how much of it that we have, we can use density to try to identify unknown substances. And so in this experiment here, we're not necessarily going to be doing exactly that, but if we had, actually we can, sorry, you can do that with the table that you have. I forgot that you had that table in the manual. And so if you look on page, sorry, let's see if I can find it here in your manual. There we go. For instance, on page 5 in your lab manual, we have the densities of some various common substances there. And so let me go even further. Yeah, similar to the density table, it's on page 13. And so what you're going to do is we're going to find the densities of these various liquids and a couple of solids. And you're going to use that table on page 13 to then try to identify what the substances actually are. Now you won't get any that are, we probably won't get any that are dead on. For instance, if looking at that table, if you found the density of something to be 7.94, then the closest to that is iron with a density of 7.86. With our tools here, we're not going to get any of these dead on, but you're going to look for what the closest one is, and it should be hopefully pretty close. And so we have a couple things that we need to think about and a couple challenges that we need to try to overcome. And so when we want more, we're first going to look at finding the data that we need for our liquids. So here we have unknown liquid 1. And so in order to calculate density, density is the mass divided by volume. We typically use units of grams per milliliter. And so I need to be able to take a sample of this unknown liquid in here, and I need to be able to find the mass of that and the volume of that liquid. And so we need to think about how to do that. I can find the volume easy enough by putting some into a graduated cylinder, and I measure the volume. But then I need a way to find the mass of that. And I obviously can't simply pour some onto the balance and find the mass of it that way. And so hopefully you thought about this in your pre-lab, the steps that you would actually take in order to find the mass of this liquid. And so what I'm going to do first is zero out my balance. I'm then going to place my 10 milliliter graduated cylinder onto the balance. And I find that the mass of my empty cylinder, and this will all be in your data form, or your data spreadsheet that we provide, but the mass of my empty cylinder is 27.921 grams. I'm then going to add some of liquid 1. Getting some pipettes that I have behind me here. I'm going to add some of liquid 1 into the graduated cylinder. Just go with a few squirts of the pipette here. Get some in here. Place this back on the balance. So the mass of the cylinder plus liquid 1 is now 35.274 grams. And so hopefully you've been able to piece together that if you take the difference of those, if I take the cylinder plus the liquid and subtract the mass of just the cylinder, that gives me the mass of the liquid. So that's one piece of the density calculation that I need. The other piece is the volume, and for that I can simply read the graduated cylinder. And when I do that, I find a volume of 6.7 milliliters. And so that was liquid 1. So now I'm just going to rinse out my graduated cylinder. I'm just going to get a different graduated cylinder. I'm going to steal one from another station real quick. And we're going to do the same thing for liquid 2. So for liquid 2, the mass of my empty cylinder, 28.289 grams. I'll put some liquid 2 in there. You'll note that another piece of lab safety, whenever I'm done using something, I always put the cap back on and then just put it away. And so the mass of cylinder plus liquid 2, 35.162 grams, which has a volume of 6.6 milliliters. Rinse this out and then go steal another graduated cylinder and leave this one to dry. And so for liquid 3, empty cylinder equals 28.369 grams. Put some of liquid 3 into the cylinder. Now again, you want to be recording in your notebooks everything that I am doing. So I first place the mass of the graduated cylinder onto the balance. Now you wouldn't need to go into that much detail. You don't have to say, put the graduated cylinder on top of the balance, but you would just want to write something to the effect of, found the mass of the graduated cylinder, because that is what I actually did. Found the mass of the empty graduated cylinder. Added some of liquid 3. So the cylinder plus liquid 3 is 37.913 grams with a volume of 9.6 milliliters. And again, all of this data will be provided for you. You can certainly write it down as I go. I will try to announce out the data as I do these experiments this semester. But if I forget, or if you miss something, all of the data will be provided in a spreadsheet for you. And so that gives us the mass and the volume information that we need for the densities of our liquids. We now need to find the densities of our solids. And so we're going to find them. I'm just going to pick a couple here at random. And so we're going to find the mass and the volume information for these two pieces of solid metal. Now for the mass is easy enough. I want to note which one I'm doing. I've got metal 16 here. And the mass is easy enough. This I can just stick right onto the balance. It was already zeroed. So my mass equals 70.059 grams. The volume of this presents another challenge for me though. And so if I was trying to find the volume of something that was a regular shape, something like this box, then okay, length times width times height, multiply those three and I can find the volume. If, however, I'm doing something that's a bit more irregularly shaped, as this is a cylinder, sure, so if I had a way to measure the actual radius, then I could use the equation for the volume of a cylinder. But even this has a number of little pock marks in it, it's stamped, and so measuring the volume of it in that way might not be that accurate. And so what I want to try to do then is find a way to measure the volume of an irregularly shaped object. And so what I can do is use a method called water displacement. And in water displacement, think about what happens when you get into a bathtub. Get into a tub, sit down in, the water rises up. The amount that water rises is the volume that you are displacing. And so we can try to do the same thing here. What I can do is add a certain amount of water into, I don't have that much water in this bottle. Not much more in this one either, but that's okay. I'm just going to add some water in there. And I'm going to measure the initial volume. The initial volume in here is 18.9 milliliters. And then I'm going to carefully, so none splashes out, carefully add in my metal and record the new volume of 25.0 milliliters. The difference in those volumes between my initial and my final, that is the volume of my cylinder. And so now I have the mass of the cylinder, I know the volume of my cylinder, I have all of the tools that I need to find the density of that cylinder. Do the same thing now for our second, number 14. I need the mass of this one as well. This was number 14. Much smaller mass of 17.302 grams. Put some water in there for an initial volume of 14.0 milliliters. Drop the metal down in. Looks like I had just enough in there. For a final volume now of 20.0 milliliters. And so again, the difference between those volumes would be the actual volume of the cylinder. And so that should be all the data that you need in order to find the densities of the 3 different liquid unknowns and the 2 different metal unknowns. And with that, that concludes Module 0. All the data will be provided in the data spreadsheet for you as well. Thanks for watching. Having trouble with my remote here. All right, looks like I have to actually turn it off manually. See ya.